Hey guys, welcome back. We have in our previous videos, we have checked on what are try block, try and except block, try and finally block, try else block. Uh, the major part that you need to look at when you're handling errors is the exception part, because that is where the errors are getting handled. Yeah. Today we'll try to understand various ways of handling exceptions. Uh, Through this entire video, we'll try to understand how we can raise exceptions, how there are various ways you can assert exceptions as well. So in when I'm talking about exception handling, so in Python, it refers to managing runtime errors that may occur during the execution of the program. Yeah. So anything that makes your program to halt because of some errors, that's where the exception handling comes into picture. Now, in exception, when it is raised, so when errors or unexpected situation arise during the program execution, such as division error or a syntax error, trying to access a file that does not exist or attempting to perform an operation on incompatible data types. So there are various type of errors that may occur which needs to be handled. Yeah, there are around I'll show you, we'll talk in our next topic is the various type of building exceptions which are available in Python. Now usually let's come back to a handling part where there are two important features towards handling an unexpected error in your Python program. Yeah, and that will add to your debugging capabilities. That is, first is your exception handling. So this is what we are going to cover right now. So when I'm talking about exception handling, this so there are various type of exception or errors which are built in Python. Yeah, we'll go through them. And second is the assertion. So assertions are usually uh, it is a kind of sanctity check that you can turn on or off when you are done with your testing. Yeah. So usually it is used during a testing phase to understand whether a particular error has been occurred or a particular testing has been completed so that all the errors are handled properly. Yeah. We'll cover the assertion part in our next video. Let's quickly jump on what is an exception. So when I'm talking about exception, an exception is an event which occurs during execution of a program. We know that, yeah, and that disrupts the entire operations. So in general, when Python script encounters a situation that it cannot cope up with, it raises an exception. Okay, so when a Python script raises an exception, it must either handle the exception immediately, otherwise it will terminate or quit the program. Okay, so handling an exception. So let me first. So handling an exception, let me put it this way. So handling an exception is in its way if you come across a code which you think will cause an error, then you can put that code in the try block and include an exception followed by it, which will handle that particular program. Yeah. So the try block contains all your statement which is susceptible or prone to an error. Yeah. Because of that code, the program will jump into an exception, and the exception and jump into an exception. And if the code executes properly, then it will not jump into an exception. Yeah. So there are three parts to exception handling. First is the try block, where you handle your code or the problematic code. If the exception occurs, the program jumps into the except block. If it doesn't occur, then it will run the block without an exception. So usually, as we have seen in the previous example, it will look like this thing. I'll show you. So usually this particular execution will look like try. You'll have a try block. Then you will have all your code which may run into error or exception. Then you have the except block, which would have small e, except with exception 1, yeah. Then you will have if the except 1 occurs, then this block will execute. Same way, we may have another exception. If you have an exception 2, then the exception 2 will run. Yeah. Else, then we have the else block. If nothing occurs, if there is no exception, then this block will execute. Yeah. I hope this is pretty clear. So there are few points that you need to understand while having an exception handle. So a single try statement can have multiple exception blocks. We can see this. Yeah. This is useful when the try block contains statements that may throw different types of exceptions. You can also provide a generate except clause which handles any exception. So if you do not know which kind of error it will throw, you can have a generic exception which will handle any kind of error. Now, after the exception clause, you need to have an else clause which will execute if none of the except clause are triggered. So none of the error occurs, then you need to have an L clause to run a particular code if the code runs smoothly. So the else block is a good place for code that does not need try blocks protection. Yeah. So these are some important things that you need to remember while running a try except block. I'm just trying to make some pointers which will help you to understand this particular thing. So let's write a particular code which will help us in understanding an exception. Yeah. So suppose I want to open a file. So I'll take the same code that we have used for file handling previously. Okay, FL. Okay, this one. Yeah. We'll try to understand this code. So what I'm doing is I'm checking whether I'm trying to open this file. I'll remove this nested. I'm trying to write to the file, hello world, this is my test file for exception handling in Python. Yeah. I'm checking if it gives me an IO error. Yeah, file cannot be found. It will give me an IO error. If this error does not occur, then the else code will run saying that print content written to the file successfully, and it will close the file. So let's try to run this particular code. Yeah. So what we have tried to do is I have tried to open the file. I tried to write to the file. Yeah. And since the file was able to write, this test file was able to be written with this content successfully, I can see the content to the file written successfully. Let me check. Yeah, so you can see the test file here. If I have to check the content of the file, test file, we can see, hello world, this is my test file for exception handling. So the content of this particular file has been returned to the file successfully. Hence, there was no error that has occurred. And we were able to jump into the else loop directly. Yeah. And F1 fl.close, which has closed this particular file. Yeah. So this is how you can handle a file by writing your content to it. And if there is any error in opening the file or an error in writing the content to the file, it will give you this error. Yeah. So suppose if I write this code with a different file name, so I'll write TT or test file 1. So let me write this way. So I have created another file. See this test 1. Yeah. So I'm creating a file and writing to it if the file does not occur. Okay. So if there was an error, it would have given me this error. If I try to, what I can do is, if I try to read, okay, I do not have a test2 file when the error would occur. So I'm trying to read this particular file. Let's see if it able to give me the same output. Yeah, file cannot be found. Yeah, previously this file was not existing, so it was creating the file and writing the content. Right now, what I've changed this parameter from write to read to check whether this particular file already exists. So if this file does not exist, then it gives me an IO error saying that the file cannot be found or data cannot be read from the particular file. Yeah, so here the exception has got triggered and we got the error. Here, the exception was not triggered because we were able to create the file and write the content to the file. Hence, it wrote the content directly. Wherein, if I try to read from an existing file. So I have created test file already and I try to read it. It will get into the test. Okay, I do not have a test file. I have it. So I have not given a write permission. Okay, I have not given a write permission. I have given a read permission. Hence, it was not able to give me the write. So here I have given the write permission. Hence, I was able to write to that file. Whereas here I have given only the read permission and I was trying to write to the file. Hence, it gave you an IO error. Yeah. So you need to understand what you're doing with a particular operations because of which you get an error. Now, you can also have a except clause with no exceptions. Yeah. So you can have a except clause with no exceptions. So it would be, this is not a good practice usually. So this kind of try except statement catches all the exceptions that occur. Using this kind of try except statement is not considered a good programming practice though, because it catches all exceptions but does not make the programmer identify the root clause. Yeah. Usually what happens is if I have to write an program which catches only general exception, you will not be able to identify the gap or you will not be able to identify where error has occurred and because of which or what was the reason of this error. So you all your code is being flashed here. I'll just not write any exception name and it will catch all the exception and I'll have the else statement. Do not bifurcate it whether you have an exception one or you have an exception two. Yeah. Hmm. Let me put it properly. Let me have it. I'm just trying to format it. Give me 1 minute. It looks properly when you're trying to use my coded file to check on what we have done in the video. So as this is a general exception that has been executed for all the errors. So irrespective whether it is an IO error, whether it is a syntax error or is a division error, all lands into this particular block. If any exception occurs. Will be executed. Okay. So this is not good practice. I usually do not follow this, but this is what you can do for a general thing, whether your program is encountering an error or not. Yeah. And that will help you to understand, just bifurcate the error and later on you can check on the specific error and throw that error into your block. Yeah. But this is not a good practice. You need to understand where the error has occurred and what kind of error has occurred. That's very important for any error or exceptional handling. Yeah. You can also have except clause with multiple exceptions. So you can have uh, multiple exceptions in except clause. Yeah. How you can do that? How you can do that is we can use the same code. You can have multiple exceptions. So you can have the except, then you have the parenthesis with exception 1, comma, exception 2, comma, exception 3, yeah, and so on till exception n. So as many exceptions you want, you can put in this particular block. So you can have multiple exceptions kept in a single block with for which you probably need to have a single line of code. Okay. So if multiple on the listed exception. Okay. If any exception or error occurs from the listed exception, this block will execute. Yeah. Or else it will execute the below block. So you can have multiple exceptions being listed in one block to execute a particular code. You can have, so what we saw is only one exception, or you can have multiple exception. Yeah. Exception with else. We have previously also seen uh, try finally exception clause. Yeah. We know what it is. I'll just cover a quick example on this. So you can use a finally block along with the try block. The finally block, as we know, is a place to put any code that executes irrespective of whether the exception occurs or not. Yeah. So you may have the syntax as so we may have syntax as try all the code that you need to, which may run into an error or exception. You will have the finally block. Yeah. Before that, you can have you can have the so Any exceptions before this will be skipped or executed. Or, and then we have the finally block. If any exceptions, it if exceptions or error occurs, uh, this block of code will run irrespective of exception or error occurs. Yeah, we know what finally blocks is. Yeah. So suppose I have this file that we had, and we say we have only this code, only the right code. We know this has executed properly. Yeah. We know that this is executed properly, but I'll just put here finally. Yeah. And I'll remove this exception. Still, it will show me this error because even though the operation was successful, it is saying me file cannot be found or data cannot be filed. Wherein this was executed successfully in a previous example, we have seen this. Yeah, content was able to be written into a file successfully. So the finally can run irrespective whether your code has run or not. Now suppose you have a nested try block with the same statement. Yeah, let me have this thing put in a nested try block. So I have this write statement. I'm saying file dot write. I'll say try. F1 dot write hello world. I'm trying to write it. And then I have this finally inside. I'll say print. I'll say closing the file. And I'll say fl dot close. And then I'll have this IO error that we executed earlier. And I'll say have the exception statement, which would give you an IO error. Okay. So let's see what happens if I try to write to a file, whether it is going through the error or no. You can see this, it has executed this file, added this particular content to it, and it has closed the file. Yeah, it has not gone into this error. So this is how you can use finally as well. So when an exception is thrown in the try block, the execution immediately passes to the final block. After all the statement in the finally block is executed, the exception is raised again and is handled in the except statement. So if present in the next higher layer of the try exception. So if this error would have occurred, it would have come out of this loop and checked whether the error has occurred, and it would have give you this error. So if I try to write, let's see if I'm able to get this. Yeah, you can see this. It has run this finally as well because it will run irrespective of your error or occur or not. But since the error has occurred, it has come out of the loop and has given you this error. Yeah. So hope you're understanding what is happening outside the file and inside the file. So I previously, when I tried to execute it by keeping a write file, which is not giving me an error, it has executed this particular thing and it has not executed this error exception. Whereas if I try to read a file which will throw me an error, it has executed this block as well as the finally block, but it has executed this error as well because the error has occurred. Yeah. So that's the way of trying finally. That's how you understand the concept of how and when to use finally and try. Yeah. You can have an argument for an exception. So when you're trying to handle exception, you can have argument of an exception which can be used towards various things. So an exception can have an argument which is a value that gives additional information about the problem which we have seen earlier. So the contents of the argument may vary by exception. So you can usually copy the content or capture the content of the argument or the exception by using an variable or an argument to it. Yeah. How you do it is this way. So you can have a try block. Yeah. So this is where all my code which may generate an exception or error. Yeah. Then you have the accept block with the exception type. Yeah. And you have the argument. Yeah. So you have the action type as you need to specify the argument. So this is how, and you can post this, you can print the argument value. So if you write a code like this, which will handle a single exception, you can have a variable to follow the exception, which is an argument. Now the variable receives the value of exception, mostly containing the cause of the exception. Yeah, we have seen this earlier as well. I'll just show you that example which we have earlier done for an argument handling. Is it, so let me write that once again. So suppose we have the program, the 10, where we have a variable. I have this program, I guess. Let me see. Okay, here. Okay. So we'll use the same program where we are using a variable as an argument. You see this? So we have this variable. We are having the value error as an argument here, and we are printing that argument through this variable. So we are storing the variable into an argument which is printing that particular argument. So I am storing this variable, so it will have the information about the argument. So this is how you can store the argument values and get it printed later on to get more understanding about the argument. So you can see here, I can get a key error. I can get what was the case. Yeah, if I say case, right, run this. So there are various things which are involved in this particular thing, which you can use for with along with this arguments to get a required output. I do not want to get into this. You can check it at a later date. Yeah, to get the error part. We'll check it at a later point. Let's get into the exact topic that we are towards exceptional handling. So there's one way of handling an argument by getting an argument passed. And through argument, you can learn or get more information about the error. That's what you need to understand as of now. Yeah. Let's jump into another way of exception handling is raising an exceptions. So when I'm talking about raising exceptions, so you can raise an exception in several ways by using the raise statement. Yeah. Here, exception is a type of exception and argument is a value for the exception argument. The argument is optional. If not supplied, the exception argument is none. So let me show you the syntax first. So what by which you will be able to understand first what do I mean by raising an exception. So it is usually used by having the keyword raise. Yeah. Then you have the exception, which is optional. Then you have the argument. Yeah. Then you have the traceback. And all these are optional. Yeah. When I'm saying an exception is the type of exception. For example, it could be a syntax error, it could be division error, or it could be any kind of error. Argument is a value for that exception argument. So if you plan to have an argument here, you can have an argument for this particular exception, and that is optional. And if you do not supply it, exception argument is none. Finally, the argument traceback is also optional and rarely used in practice. So if present is the traceback object towards the exception. Yeah. So let me show you an example. So an exception can be a string. So suppose I have this function, I'll say def name, I'll have this. Yeah. Now if LVL is less than 1, I'll say raise invalid label, and I may have the argument as level, LVL, sorry. Yeah. So what happens here is the code to this will not be executed. Yeah. If we raise the exception. So in order to catch an exception, an except clause must refer to the same exception thrown either class object or simple string. For example, to capture above exception, this particular exception, we must write the except clause as follows. So what we can do is we can write try your yeah, function name -10, which is less than 1, except invalid level as E, and it will print as invalid level. So this will capture the, can see this? Catching classes that do not inherit from base exception is not allowed. Yeah. So this is where your entire block of code get invalid because the function itself is here and it has raised this particular exception. Yeah. So the error itself says, see, during handling of the new exception, another exception occurred. So this is where our exception occurred since we raised it. Yeah. So let's get into another way of handling. We understood what is raising an exception. So this is how you can raise an exception. Yeah. Another way of handling exception is having a user defined exception. So I can have a user defined exception. So usually a Python allows you to create your own exception by deriving classes. So you need to define a class to run an exception. Yeah. As compared to a standard building. We'll see the building exception in our next videos, subsequent videos. We can have a runtime error. Let's try to have an example. Okay, user defined class. So this usually helps in creating your own exception through user defined classes. Yeah. So how do you do that? Let me show you class. Suppose I have this class with my error class, my user defined error, and then I have an error called runtime error. Okay. So I have a class which has a runtime error, and I give a have an function within it. It is self-defined using the argument. Yeah. Let me run this so that I have this class created with the function. Okay, let me see runtime. Okay, I have spelled it incorrectly. Let me have this runtime error. Okay, so I have created a class in which I have this init class which runs by default. We'll check it in the class module which we have created, where this is our initial class which initializes this user defined class. So this is an initialization where we have self and the argument by default. Yeah. What we are trying to do is we have tried to run this class by executing it by having the function within the class. So how do I call the function within the class is first calling the class itself. So I'll say try, you can raise it, user defined, and I'll say my user defined error. Yeah, so I've raised it. And I'll have the except clause with my user defined exception and the argument as MUD. Yeah, so which is a user defined argument that I have given. And I'll try to print mud, which is the argument that he had and the argument value here. Yeah, so let's run this. Let's see what is the output. Multiple exceptions type must be parenthesized. So let me check where I have done anything incorrect. File my user multiple exception. Let me fix this error. Let me see. Okay, as mud, we need to define, okay, argument as mud. So I have defined with a comma, wherein I should have defined it as mud. So you can see this, my user defined function has been executed. So it has taken each individual characters from this particular statement and it has printed here in a form of a tuple. Yeah. So what is happening here is I'm trying to raise my error. It is taking my exception since an exception has occurred because this particular function is being pushed here. Yeah. And then it is running my default argument into this in my initialization, which is giving me this output. Yeah. So here, this example is related to a runtime error. Here, a class is created, then it is subclassed from runtime error. So you have a subclass within runtime error. This is useful when you need to display more specific information when an exception is caught. Yeah. So in the try block, the user defined exception is raised and caught in exception block. Yeah. The variable E or the mud, yeah, is used to create an instance of the class my user defined error. Yeah. So this is how you can have a user defined exceptions been created and thrown when you encounter an error. So the point here is just leave aside the class, how it is being handled. Do not try to get into how class is created and what do you mean by in. The point here is to understand is you can have your own errors being created and you can use those errors to define a specific type of exception that occurs within your code. I hardly use this, but definitely you need to know this because of which I've tried to cover it. Do not try to get bogged down by understanding what is class, hence I'm not able to understand. The point here is to understand that you can have a user-defined exception. The point here is through this video, you need to understand various ways in which you can handle exceptions. You can have a single exception. You can have multiple exceptions handled through a particular code. You can have user-defined exceptions. You can have argument for your exceptions. You can raise your exceptions to another level by which you can have your error been stressed on. Yeah. Apart from this, you have user or built-in exception, which we'll cover in our subsequent videos. So stay tuned for it. Hope you like this video. Hope you understood the various type of exceptions that are available in various type of ways in which you can handle exceptions in Python. Hope you like this video. Do like it, share it across to your friends who want to learn Python. Do comment on the video if you have any views or feedback on this particular topic. Yes, but do not forget to subscribe to my channel in case if you like to get all the uploaded videos directly to your inbox. Thank you so much.